Oftentimes, when you're doing a study, you always want to ask yourself, how large does my sample size need to be so that I can estimate for some population parameter? In this situation, maybe it's a population proportion, and have some level of confidence in my estimation as well as be within a certain percentage for my margin of error. So there is a formula for calculating how large your sample needs to be. In other words, there's a formula for calculating your sample size. So if we are interested in estimating for a population proportion, so let's just remind ourselves that a population proportion is some p-value, then the formula that you use is you would use n equals your critical value of z sub alpha divided by 2 times p hat times q hat and divide that by your margin of error squared. And keep in mind here that your margin of error, when you put it into the formula, if you are given the margin of error as a percent, you want the decimal equivalency, okay? All right, so this means that we need to know what p hat is. And then let me talk about q hat because we haven't seen that notation yet. Q hat is just the complement of p hat. So let's say, for example, I'll do it off on the side here. Let's say p hat is the proportion of births that are girls. And so if that proportion is 0.95, then Q hat is the proportion that are not girls, aka the proportion that are boys. So this would just be 1 minus p hat, or 1 minus 0.95. So if 0.95 is the proportion of births that are girls, then Q hat is 0.05, which is the proportion that are not girls. Okay, so that's what Q hat is. Okay, so in this particular problem, we want to know how many randomly, oh, let me use a different color here. How many randomly selected sales transactions must occur in order for us to determine the percentage or the proportion that transpires on the internet. So here we want to know, what is P equal to? So here P represents the proportion of sales on the internet, sales that occur on the internet. And we want to assume that we want a 99% confidence interval with a margin of error to be no more than 2%. So my confidence level is 0.99, which means that my significance level, or alpha, is going to be 0.01. Therefore, alpha divided by 2 is 0.01 divided by 2, or 0.005. And if you've watched the previous videos and the other examples, you'll see that the critical value that corresponds with an area to the right of 0.005 is a critical value of 2.58. So that, if you're not sure how to get that, you would use inverse norm. So please watch one of the previous videos on how to get that critical value. Okay, now the only other piece of information, oh, let me write down my margin of error here, 2%, and then go ahead and convert that to the decimal equivalency. And so the only other piece of information I need is p hat. Now, as I read this problem, notice that p hat is unknown, meaning that I'm not given any other information about a previous sample proportion or a p hat. So anytime that p hat is unknown, we're going to use a conservative value for p hat. So what we're going to do is we're going to use the conservative value of 50%, or 0.50. And you're always going to use this when p hat, again, is unknown. So if p hat is 0.50, then that means that q hat is also 0.50, because that's 1 minus 0.50. So let's put everything into our formula here. So that's 2.58 times 0.5 times 0.5. Divide that by 0.02 squared. And then if you put this into your calculator, 0.5 times 0.5, you'll see that's 0.25. So a lot of times you'll see that in the general formula for calculating the sample size when p hat is unknown. And so when we do this calculation, it turns out that we need at least 4,160 sales transactions or larger. So 4,160 or larger, right, in order for us to estimate for P with 99% confidence and be within a margin of error of 2%.